viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani from Department of Computer Science, Aryabhatta College, University of Delhi. So let us begin with our today's lecture, which is on SQL, as we are going through the commands of SQL in our present series, which is database management systems. And today we are, along with other various commands of SQL, we are going to deal with one which is a very common situation, which is ordering, or we can simply say sorting. So basically it is actually we want some list in alphabetical order. For example, the names of instructors. So names of instructors, we want the whole relation arranged in the alphabetical order on the basis of names of the instructor. So we are going to write select name from instructor order by name, or we can also write select star from instructor order by name. So order by is the actual clause. Order by name, that means alphabetical list or sorted list will be prepared by name, and we can also write the name of any specific field if we want here. So for example, we can write select name comma department or select name comma salary from instructor order by name. We can also use the clause which is distinct. So distinct is basically in order to remove all the duplicates. So order by is the clause which is going to give us the relation in a sorted manner, order by according to the field which is specified as the parameter of the order by. If we want to specify the descending order, we need to specify DESC. So this will be the whole thing will be select name from instructor order by name DESC, DESC as in descending. So ascending order is by default, we need not to specify anything, and if we want this the relation to be sorted in the descending order, we will be writing order by name descending. Now this order by clause can operate on the multiple attribute. For example, we can say order by department name comma name. So department name will start working, department name here will work as a primary key, and whatever tuples are there in the relation with the common department name, they will be arranged on the basis of the next one, which is the name. So we can have multiple attributes. For example, we can say order by department name comma name. With this, we will be looking into, apart from this sorting, we will be looking into some more predicates of this where clause. This where clause is also going to is also used for the comparison operator. So comparison operator, for comparison, it is going to include a clause which is named as between. So for example, let us say we want to write names of all instructors with salary greater than 90,000 and less than $1 lakh. So we can write select, either we can write where salary greater than 90,000 and salary less than $1 lakh, or simply we can write select name from instructor where salary between 90,000 and 1 lakh. So this is the use of between. We can directly use for this instead of 1 greater than equals to clause along with 1 less than equals to clause connected using the and. So simply we can write between. This is a we can say this is much more simpler than the other one. Apart from this, this where clause also have other predicate for tuple comparison for not only the numbers. For example, this can have select name comma course ID from instructor comma teaches. Now instructor comma teaches, that means there is a Cartesian product involved where instructor dot ID comma department name is equals to teachers dot ID and biology. So instructor dot ID will be compared with teachers dot ID, and department name will be compared with biology. So this is going to give me the name and course ID of all those instructors which belongs to biology department and have taught some course. So, for taught some course it is instructor ID equals to teacher's ID, and for belonging to biology department it is department name equals to biology. So, this is what we can use if we want to use some comparison. We can use for numbers or we can use for the tuple values. So, next, if we want to use our various set operations also there, which we have seen in relational algebra. For example, we have set union operation, we have set intersection operation, and we also have the set difference operation. Now, here in our relational algebra, we have seen how are we going to write that union operation is going to be written with the help of its symbol u. The intersection operation is going to be taken with the help of its symbol, which is inverted u, and the set difference for the symbol for the set difference is the symbol of the subtraction, which is minus. But here, for taking the set operations, if we want to write the all queries, we will be writing queries like this. So, for let us take the example of union. So, we want to have all the courses that ran in fall 2017 or in spring 2018. So, here we are going to write select course ID from section where SEM equals to fall and year equals to 2000, union select course ID from section where SEM equals to spring and year equals to 2018. So, here this is going to give me a union of the courses or the total list of the courses that ran in fall 2017 or spring 2018. So, here basically we can say two criterias, or more specifically 4 criterias are specified by using the OR clause or thing. One is the SEM equals to either the fall or spring, and the next one is year is equals to 2007 or year is equals to 2018. So, here we in this way we will be writing the set operations, which is the union. Now, let us take another example of intersection. So, intersection says the query belonging to intersection is will go like this: find courses that ran in fall 2017 and in spring 2018. So, we will need, because we are using the term and we are we require here an intersection. So, we will be selecting courses from section which belong to fall 2017 and also belongs to spring 2018. So, here we need the intersection, and the clause or the term here which is being used for intersection set operation is the term here is the intersect. So, we will be writing select course ID from section where SEM equals to fall and year equals to 2017. This query will be written in bracket, intersect select course ID from section where SEM is equals to spring and year is equals to 2018. So, these two queries will be we can say executed single handedly or executed parallelly, and the result from one query and the result from another query will be combined using the operation of the intersection. That means whatever rows or whatever tuples which are common in between both of them will form the resultant relation. Apart from that, the set operation which is there along with the union and the intersection is the set difference. So, set difference says, for example, there are two sets, let us say a set A and set B, and if I am looking for A minus B, that means I am looking for all those values which are there in A but not there in B. So, that is what the set difference operation is. So, we can say find courses that ran in fall 2017, but not in spring 2018. So, fall 2017 is the set A minus spring 2000, that is the set B. So, we will be looking for A minus B, and the term here is the except, EXCEPT, which is going to represent the set difference. So, we will be saying select course ID from section where SEM is equals to fall and year equals to 2000. This end is written in order to complete the, we can say, clause which is fall 2017, except select course ID from section where SEM is equals to spring and year is equals to 2018. So, whatever is going to be the result of query 1 and whatever is going to be the result of query 2, a set difference between them is being taken. That means all the tuples which are present in one but not present in the second one will be taken and given as the result. Now, please remember these set operations which are union, intersect and except, they are going to eliminate the duplicate rows automatically. That is the by default setting. If we want to retain all the duplicates, we need to use union all, intersect all, except all. Just we will be writing the clause all along with the union, intersect and except. One very important concept which comes here in SQL, that is about null values. Null means actually kind of we can say nothing. So, it is possible for a tuple to have null value, and this value is denoted by the term null, which is null for some of their attributes. It's possible, it's perfectly possible for a relation or for a tuple to have a null value for some of their attributes. So, this null basically signifies an unknown value or that a value does not exist. So, for example, we are going to write an arithmetic expression or any arithmetic expression which involves null, the result is going to be null. So, for example, if I am going to write 7 plus null, it is going to return null. Now, the term null can be used as a predicate in the form of is null, where we want to check the presence of null values. So, for example, if we want to see whether that there is is there any instructor whose salary is not being kind of we can say entered, or salary is not being fed, or we can say whose salary is null. So, if we want to find all the instructors whose salary is null, we will be writing the query as select name from instructor where salary is null. So, is null will look for all those names where the salary is not given or the salary is null. So, the opposite predicate of is null is actually is not null, which is going to succeed if the value on which it is applied is not null. So, the value which is going to on which it is going to be applied is not null, then this predicate is not null is going to be succeed. Apart from this, these can be used along with the Boolean operations like AND, OR and NOT. These null values can be combined using the way or within the where clause. These can be combined with unknown values, or you can use the AND, OR and NOT operator for this. So, for example, the definition of the Boolean operations needs to be extended to deal with the value of unknown. So, for example, we are going to write true and unknown will be unknown, false and unknown will be false, and unknown will give you the result as unknown. When we are going to use these Boolean operations, which is we have just seen the AND, we can also see the Boolean operation which is OR. So, unknown or true is true, unknown or false is unknown, and unknown or unknown is unknown. So, result of the where clause predicate is treated as false if it is evaluated to unknown. This is something important which we need to be careful with. The next subtopic which comes is aggregate functions. So, aggregate functions are basically the functions which operate on multi set of values of a column of within a relation. So, within a relation we have various columns, and there are functions which are going to operate on multi set of values of those columns. These functions are known as aggregate functions, and we have typically we have 5 of them, which is one is AVG, average value, then min for minimum, then we have max, which is for maximum value, and then we have sum, which is sum of values, and then we have count, which is number of which is counting the number of values. These average, min, max, sum and count are aggregate functions, and we will be looking at the use of these aggregate functions with the help of examples. So, for example, we want to find the average salary of instructors in the department of computer science. So, we will be writing select AVG, and within the bracket we are going to write the column on which we want to apply this average aggregate function. So, we will be writing select average salary from instructor where department name is equals to computer science. So, this will give me the average salary of the instructors in the department of computer science. Then if we want to find the total number of instructors who teach a course in the spring, so spring 2018 semester, so here we will be writing, he will be using the aggregate function which is count. Now, the query goes like this: select count distinct ID from teachers where semester is equals to spring and year is equals to 2018. So, now we all understood of this the usage of this where clause, where we are saying semester is equals to spring and year is equals to 2018, and we have written spring within the single inverted commas because that's kind of group of characters, that's a string, and 2018 is basically a number here. And here we have written select count distinct ID from teachers. Now, select count distinct ID from teachers actually going to count the total number of tuples or total number of IDs from teachers where this clause is being satisfied. Also, we have not just written ID. The query is select count, query is the select count distinct ID. We have not written select count ID. So, that means this is going to, we can say, eliminate the duplicates. So, if we want to eliminate the duplicates, and that goes with along with the aggregate functions, this distinct term or this distinct clause goes with the count function rather than this max min. So, we will be writing select count distinct ID from teachers where semester is equals to spring and year is equals to 2018, or any other we can say where clause for that matter. Now, if we want to find the total number of tuples in a particular relation, so that is even easier with the help of this aggregate function which is count. So, in order to retrieve all the tuples from a particular relation, we write select star from the relation name. But if we want to count the number of tuples, and we do not want the tuples in detail, we just want that count. So, we will be writing select count star from course. So, select count star from course will give me the number of tuples in the course relation, and the answer or the resultant relation will be just one column, one row relation having the count as the whatever the count is there. For example, course is having, let's say 17 tuples. So, the result will be count star and the value of that particular cell will be 17, that is it. Now, similarly, we can write select maximum within the bracket salary from instructor. So, that is kind of it is asking for the maximum salary of the instructor. Similarly, we can ask select min within the bracket salary from instructor, that means we are looking for minimum salary. So, we can write average, we can write minimum, we can write maximum, or we can write even the count. These are actually aggregate functions, but these aggregate functions actually grow go very good, or they gel perfectly with the group by clause. So, group by clause is there in order to find the subgroups within the relation, we can say. So, for example, if we want to find the average salary of the instructor in each department. So, what we need to do initially, if we see, we need to make the groups of the department, and then we will be finding the average of the salary which are available within that group. So, here for this what are we going to write as a query? Select department name, average salary as avj underscore salary, or we can remove this renaming of the column from instructor group by department name. That means whatever rows or whatever tuples are there within the instructor, those are to be grouped on the basis of department name, and this average salary is being, or this average aggregate function is being operated on each and every individual group. So, we can use this aggregate functions on the group by clause by writing select department name comma average salary from instructor group by department name. So, here this is going to be the result if we are going to write that particular query. Here the instructor table is given, and if you can see on the screen, this is having two tables. One is the table which is the original instructor table, and another table is the resultant table which is coming from the we can say your which is coming as the result of the execution of this particular query, which is select department name average salary from instructor group by department name. So, here is the we can say result. In the instructor table we have ID, name, department name, and salary, and all these departments in the instructor relation, if you can see, are demarked with the help of some horizontal lines. So, the first one first record or first tuple is belonging to department name biology, the other three belongs to computer science, then there is one from electrical engineering, then two from finance, two from history, then one from music, and two from physics. So, here we can see that the grouping goes like this. Biology is having only one record. So, the average salary is the similar as the record, which is 72,000. Then computer science, belonging to computer science, there are three records. Average is being found out within that particular group and written. Then electrical engineering, only one, which is 80,000, written as it is. Average for two of the records, two of the tuples belonging to finance has been taken out. Similarly, for the history and physics and music is having only one particular salary. So, you can see the grouping on the basis of department name, and after grouping the average salary is being we can say determined, and that average salary is being written here. So, this is what the use of an aggregate function along with the group by clause. Now, here there are some rules and regulations related to aggregation. Attributes in the select clause outside of the aggregate functions must appear in the group by list. So, for example, if I am going to write select department name, ID, average salary from instructor, the group by department name, this is going to be an a query with the error, because the attributes in the select clause which are outside of the aggregate function are not appearing in the group by list. So, the group by list must contain the aggregate functions which are outside the attributes of the select clause. Apart from this, group by, so for example, we need to apply some predicates, or we need to apply some clause as we have applied on the individual functions, not the aggregate functions, but the individual functions, and that can be done with the help of where clause. Here this can be done with the help of having clause in case of aggregate functions. So, find the names and average salary of all the departments whose average salary is greater than 42,000. Now, the moment we are going to write whose average salary is greater than 42,000, the first thing which comes up in our kind of mind is the use of where clause. But please beware that here we are looking for the average salaries, and average is actually an aggregate function. So, wherever we are using aggregate functions, we need to use the clause having, we cannot use the clause where. So, here it goes like this: select department name, average salary from instructor, group by department name, having average salary greater than 42,000, not the where average salary greater than 42,000, because average here is an aggregate function. So, aggregate function, if a condition depending on aggregate function has to be specified, that will go with the having clause, not with the your where clause. Also, we need to note down that the predicates in the having clause are applied after the formation of the groups, where the predicates in the where clause can be applied before the formation of the groups. So, here we have seen in this lecture, we have seen the use of having clause, we have seen the use of various aggregate functions, and apart from that we have also seen the usage of null values and some set operations, namely set union, set intersection, and the set difference operation as used inside as used in the queries of the SQL. Hope you have enjoyed the lecture. Here is a list of references which is being used for the preparation of the lecture. I will see you in the next one. Till then, take care. Goodbye.